Hi, last time we explored the physics concept work. In this video, I explain the another key concept, energy. We know that without energy, there is nothing in the world can happen. Every activity in our daily life need energy. Work and energy are directly relative and have the same units. The work is the process of energy, and energy is the capacity to do work. The word energy is derived from Greek word energia, and the word is later named as energy in the modern science by a great physicist Thomas Young. There are many important forms in the energy. Important forms of energy mentioned here: mechanical energy, sound energy, light, chemical energy, nuclear energy, electrical energy, and heat energy. These energies can transfer from one form to another form, but the total energy in the universe kept constant. The energy is broadly categorized into two main types. The first one is kinetic energy, the second one is potential energy. The first one is kinetic energy. The energy is acquired by the object due to its motion is called kinetic energy. By this activity, I explain how the kinetic energy is formed and how the kinetic energy imparts work among the objects. Let us discuss all the apparatus set as showed in the diagram. A trolley is fixed in the position. The trolley is connected through a string to the van suspended. We can use the known masses in the van. A wooden block placed in front of trolley. By this activity, we can clearly observe while we increase the masses in the pan, the velocity of trolley increases and the trolley gets motion. After getting the motion in the trolley hits the wooden block and displaces the wooden block to a displacement S. The position of wooden block showed from here. What we have to conclude through this activity. Just we discussed the kinetic energy is acquired by the objects while it gets motion. So, when the objects get energy, has capacity to do work. That work is nothing but called kinetic energy. When we put the mass in the pan, the gravitational force pulls the pan towards downwards. The reason causes motion among the trolley and the velocity of motion increases from 0 to v. When the trolley gets motion, according to definition, it acquires kinetic energy. Due to this kinetic energy, it has capacity to do work, then it hits the wooden block. At the same reason, the wooden block gets energy from trolley and again it has capacity to do the work from this position to this position. Here the object wooden block has capacity to do work done. That work done is nothing but called kinetic energy. So the kinetic energy is equal to work done. And expressed in the formula 1 by 2 mv square. M is the mass of the object, v is the velocity of the object. The kinetic energy is a scalar quantity. It has only the magnitude, has no direction. That is the reason kinetic energy is also a scalar quantity like work. Just for the observation, by this activity, we can conclude if the mass increases, the kinetic energy is also increases and attains the velocity of the trolley is also here increases. So the kinetic energy of an object is increased by increasing its mass and velocity. Some examples for objects having kinetic energy. A falling coconut from a tree has kinetic energy due to the acquiring motion, and a flying aircraft, a flowing water, a rolling stone, moving bullet, blowing wind, and running athlete. All these are having kinetic energy due to these motions. Now, derivation of kinetic energy Ke is equal to half mv square. Consider the object is moving with uniform velocity v when the force applied on the object is F. The object gets the displacement is denoted by S. Let the mass of the object is m. Before the motion of the object, the initial velocity of object is u. Here, after applied the force, the object gets the motion and acquires the acceleration is a. We know that the force applied on the object is F is equal to ma. And again, The equation of motion relates between uniform velocity v and the initial velocity u, the displacement s and acceleration a is v square minus u square is equal to as. Put the equation as 2. By the equation 2, we can written for displacement s is equal to v square minus u square by 2a implies v square by 2a because u is equal 0. At rest, the initial velocity is 0. Here, the work done by the object W is equal F into S. Substitute the values of F and S in this equation. We have M into A into V square by 2A. Cancel A gives 1 by 2 mv square. This is the equation of kinetic energy 1 by 2 mv square. Here the kinetic energy of the object causes the object to do work done. So the capacity to do work done is called here kinetic energy. That is the reason finally we have K is equal to half mv square. The units of kinetic energy are measured in joules. Joule is the unit and named after a great physicist James Prescott Joule. This is the expression for kinetic energy. Next, the potential energy. The energy acquired by the object due to its position or in field is called potential energy and represented as simply PE expressed as mgh. Let us derive the expression for potential energy P is equal to mgh. In this diagram, the mass of the object is mentioned as m. Showed here path 1, path 2. The force applied on the object to raise the height against gravity is F. So that F is written as mg. M is the mass of the object. Here the g is acceleration due to gravity. The object is raised to a height h, so the height h is treated as displacement. Is equal h. Here the force is written as mg because it is equal to the weight of the object. And again mentioned displacement S is as h. Here, the object acquires potential energy due to raised height h against the gravity. So, the object now has to capacity to do work. That work is equal to potential energy that can be expressed as F into S. Here F is mg and S is h. Therefore, the equation for potential energy is equal to mgh. The example for potential energy: a ball held at a height, a stretched rubber band, a compressed spring, and water stored in a dam. Next, the law of conservation of energy. The law of conservation of energy states that the total energy in the universe is constant. One form of energy is transferred into another form, but the energy is neither created nor destroyed. We are observing in many situations one form of energy is converted into another form. For example, the chemical energy is converted as mechanical energy in the vehicles. Similarly, a coconut falling from coconut tree, the energy of coconut transferred from potential energy to kinetic energy. Similarly, the chemical energy in the battery converted as electrical energy. The electrical energy is converted as heat energy. The heat energy is converted as light. Thus, we can say so many examples under the law of conservation of energy. In this video, I explain different types of energies and the main categorization of energies, that are kinetic energy and potential energy, the derivations to kinetic energy and potential energy, and law of conservation of energy, all are explained in this video. In my next video, I explained to solve the problems from physics from these topics of 9th class and 10th class textbooks. Thank you very much.